Okay, okay, let's start na. So, good day everyone. This is group 2 and for today's presentation, we'll talk about the discrete sensing devices. What is discrete sensing devices?
Discrete or digital sensing is ubiquitous in automation. It has been used since the days of relay logic, before programmable logic controllers even existed, and it is used today continues to simplify logic in a PLC. A discrete sensor sends an on and off or yes or no signal, often allowing the PLC to ignore analog threshold, deadband, detection, speed, and other complexities. So, from the words sensor itself, a sensor is a device that detects and responds to some type of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, or any one of a great number of other environmental phenomena. A discrete sensor, on the other hand, outputs a high or a low voltage only. This is derived from the binary number system where the only possible digits are 0 and 1, which can represent low and high respectively. High signals, even though they are represented as 1, even in some PLCs, are not represented by 1 volt. PLC usually runs on 24 volts DC.
Types of discrete switches. First is photoelectric sensor, red switches, proximity switches, and limit switch. So, first is red switches.
So reed switches. So the switch is an electrical switch operated by an applied magnetic field. It was invented in 1922 by Professor Valentin Kovalenko at Leningrad Electrotechnical University and later evolved at Bell Telephone Laboratories in 1936 by Walter B. Elwood into the reed relay. So, the reed switch is an electromagnetic switch used to control the flow of electricity in a circuit. They are made from two or more ferrous reeds encased within a small glass tube like envelope, which become magnetized and move together or separate when a magnetic field is moved towards the switch. So, the switch effectively works like a gate or a bridge in an electric circuit, so when the two reeds are in contact, electricity can flow around the circuit, operating a device. Unlike mechanical switches, they do not require something or someone to physically flick them on or off. So there are two types of reed switch, the normally open and normally closed. So in a normally open switch, the two reeds, which are made from ferrous material such as a nickel iron alloy, are positioned so that they are not touching. So when a magnet is moved close to the switch, it pulls one of the reeds towards the other so that they are touching, and therefore, completing the circuit, remove the magnet and reeds return to their original position, breaking the circuit. So the other one is normally closed. Switch works in the opposite way. When no magnetic field is present, the reeds are in full contact, the electric circuit is complete, and the device is on. When a magnet is moved close to a switch or the switch close to a magnet, the reeds repel one another and split apart, breaking the circuit. So there are advantages of using reed switch. So number one is no mechanical wear. So because there is no physical pressure light to the switch, there is no mechanical wear and tear. Number two is operated through a non-magnetic material. So, sensors can be developed with such sensitivity that they can be embedded deep within an assembly out of sight, but still actuated by a reasonable, strong but discrete magnet. Number two is no supply of voltage. As they are triggered by magnetism, there is no voltage required. So now, so the other one is compact. So reed switches are incredibly compact compared to mechanical switches. The last one is atmospheric corrosion. As the contacts of a reed switch are sealed within a glass tube, they are protected from atmospheric corrosion. So, where are reed switches used? So, it can be used in alarm systems, laptops, safety, and automotive, and refrigerators. That's all.
Next is proximity switches.
A proximity switch is used to determine how close an object is or the proximity of an object. The proximity of an object is determined by using certain means such as magnetic, electric, or optical. So this switch can be used to check the presence of an object, and this switch is widely useful for many security processes. It can also be used to check the motor rotation speed. Switch can detect the approach of a metallic device part with the help of a magnetic or electromagnetic field. And proximity switch is a term often used interchangeably with proximity sensor, but the two should not be confused because a proximity sensor is a non-contact component which detects the presence of objects within its sensing range, while a proximity switch is a specific component which opens or closes the electrical circuit when the sensor detects the absence or presence of an object. So we have here the four basic type of proximity switches, which are infrared switch, acoustic, capacitive, and inductive. And first, we have infrared switch. This work by sending out beams of invisible infrared light. A photodetector on the proximity switch detects any reflections of this light. Next is acoustic switch. These sensors are similar in principle to infrared models but use sound instead of light. They use a transducer to transmit inaudible sound waves or various frequencies in a preset sequence, then measure the length of time the sound takes to hit a nearby object and return to a second transducer on a switch. So third is capacitive. The Bluetooth device is ready to pair. Capacitive switches. These switches sense distance to objects by detecting changes in electrical capacitance around it. And lastly, we have inductive switches. This switch rather sends distances to object by generating magnetic fields. They are similar in principle to metal detectors. A coil of wire is charged with electrical current, and an electronic circuit measures this current.
So next is a photoelectric sensor. A photoelectric sensor is a device used to determine the distance, absence, or presence of an object by using a light transmitter. Often, infrared and photoelectric receiver they are largely used in. So, kaning photoelectric sensor, ginagamit gini siya sa mga planta like Coca-Cola. For example, Coca-Cola. Ang kaning photoelectric sensor, ma-sense niya ang botilya if ever na ay gamay nga sayop or let's say sa iyahang taklob nga maybe wala na seal og ayo so iyan ang ma-sense. So natay types of photoelectric sensor. Three major types, which is the through beam. Kaning through beam, kuan siya, detect and count parts. So mo to siya ang kuno brag principle sa photoelectric sensor mo siya ang through beam. Then the retroreflective, kaning siya kay masense niya ang object sa layo pa, then pag nagpaduol na musiga siya, no, kung duol na ang object. And lastly is the diffuse, which is used reflection to detect the presence of object. So kaning diffuse, ma-detect niya ang object kung naa ba or wala. So kung wala, murag mo stop kadyot ang program, then pag ma-fix na sa gakuan, example let's say sa PLC, mo balik ra po dayon siya. So next is the limit switches. A limit switches is an electromechanical device operated by a physical force applied to it by an object. So this report is kay Jasper unta but wala siya. So mag-cite lang kog example ani. Ang example ani is kanang automatic garage door. Diba ang kanang garage kay makita na to sa mga movies sa mga sa Hollywood, diba nga kanang automatic kay lahang garage. So kani siya ginagamit ni siya kay masense niya kung naba ang sakyanan padulong or wala. Kung naa, mo-open siya. Pero kung wala, kung musulod or wala, close siya. So kung walay limit switches, magsige na siya open ba kay syempre wala goy ga control sa program. So mura na. So this was prepared by group 2 and its member. That's all. Thank you.